Hello everybody. Today I can find missing sides of similar triangles using HLLS and reducing radicals. So basically we're combining HLLS with reducing radicals. So let's just talk a moment about HLLS and let's talk a moment about reducing radicals. When you have an altitude drawn to a right triangle, here's my right triangle, my leg, my hypotenuse, an altitude is drawn, breaking the hypotenuse into two segs. Whenever you see this picture, your two proportions are hills and SAAS. If there's an L involved, we use hills. If there's an A involved, we use SAAS. So we already did a lesson on that. If you're not comfortable with it, you can look back at that. We also did a lesson on reducing radicals, so let's take a moment now and go over that again quick. So let's just write out our perfect squares, because whenever you're reducing a radical, you should have your perfect squares written out. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. That should be good enough. Make that a little bit smaller so we can fit it. And let's say I wanted to reduce radical 12. Well, since 12 isn't on my list, I break it down into perfect squares and non-perfect squares. If you're using the calculator, you're going to type in the number that you want to divide to, the number that you want to reduce, 12 in this case, divided by x. You're going to go to your table. You're going to look in your y1 column, and you're going to look for the largest number that's in the y1 column that's on your perfect square list. 12 isn't, 6 isn't, 4 is. So 4 is the perfect square, 3 is the non-perfect square. That's step 1. Step 2 is to take the square root of the perfect square, and the non-perfect square comes down, and that would be your answer. So listen, that's just one example, but you know, if you're not comfortable with it, practice your reducing radicals first. And if you were doing this without the calculator, how I like to do it, I'm trying to reduce 12, so 12 would be here. Can I divide 12 by 9? No. Can I divide 12 by 4? Yes. So let me just copy and paste this perfect square list, because whenever we're reducing radicals, I want you to have that to refer to. And I see my HLLS picture, so it's a good idea whenever you see this picture to write HLLS, so at least we know what we're going to be doing. Again, it looks like a big hill. It has all the information in. It's asking for CD, so I'm going to put an X to what I'm trying to find. To determine if it's hills or SAAS, is there an L involved or an A involved? Well, there's an A involved. The A is labeled with an X. The legs are blank. So since there's an A involved, SAAS. S over A equals A over S. S is 3 over A is X equals A is X over the other S is 4. Cross multiply and solve. I get x squared equals 12. Square root, square root. Now, since it's asking for it in simplest radical form, I have to reduce this radical. 12 is not on my list, so I'm going to break it down into perfect squares and non-perfect squares. Is this the same exact one we just did? Yeah. So again, if I'm doing it without the calculator, 9 doesn't go in to 12, 4 does. So 4 is my perfect square, 4 times 3. And then I take the square root of my perfect square. The non-perfect square comes down. And 2 red, 3 would be my answer. So it's the same thing that we did in our regular HLLS lesson, except now we're going to end up reducing a radical. And on the Regents, they love to give you HLLS problems where you have to reduce a radical. It's very common. All right, number 2, blah, blah, blah. I see HLLS. You recognize the picture. It's asking for AB, so I put an X of what I'm trying to find. To determine if it's hills or SAAS, I need to determine if there's a leg involved or an altitude involved. In this case, there's a leg involved, so I'm going to use H over L equals L over S. H is 12. Again, expect to have to add or subtract whenever you're doing hill, SAAS, or candy corn problems. Over L is X equals L is X over S. Well, there's 2 S's. Which one do I use? If I'm using the left leg, I use the left seg. If I was using the right leg, I would use the right seg. Now that I have my proportion, I cross multiply and solve. X squared equals 24. Square root, square root. As you can see, the answers are in simplest radical form, so I'm going to have to reduce the radical. I want you to reduce the radical on your own right now. I'll give you about, I'll pause for about 20 seconds. Reduce the radical, try reducing the radical on your own. Okay. Perfect squares and non-perfect squares. If I'm doing it without the calculator, 24 would fall here. I can't divide 24 by 16. I can't divide 24 by 9. 4 goes in. 4 times 6. That's step 1. Step 2 is take the square root of the perfect square. The non-perfect square comes down, and your answer would be choice 3, 2 rad 6. That's basically it. It's the same thing that we did with HLLS, except now you're going to have to reduce a radical at the end. So I want you to try 2 of them on your own. Why don't you try 3 and 4 on your own right now? So please pause it, try 3 and 4 on your own, then unpause it, and I will go over 3 and 4. And then there's one more question I'm going to go over later on. So please, right now, try 3 and 4 on your own, pause this, and when you're done with 3 and 4, unpause. Okay, now that you tried 3 and 4 on your own, I'm going to go over them. What is the length of AB? So put an X on what you're trying to find. You might need to turn your head a little bit to see what's going on here. I recognize that this is a HLLS problem. Is there an H involved or an L involved? There's an L involved, so I'm using HLLS. If I'm using HLLS, I'm going to need to add those together to find H. So H over L equals L over S. 15 is H, L is X, L is X, S. If I'm using this leg, I'm using this seg. Cross multiply and solve. X squared equals 45. Square root, square root. Now it's time to reduce the radical. Whoops. So I'm going to have my perfect square list written out. Obviously, you can have your perfect square list on a separate sheet of paper, so you don't have to keep on writing it. 45 would fall here. I can't divide 45 by 36. I can't divide 45 by 25. I can't divide 45 by 16. I can divide 45 by 9. So 9 is my perfect square. 5 is my non-perfect square. Rad 9 is 3. 3 rad 5 is your answer. And again, to reduce the radical, if you don't know what divides into anything, you can go to your calculator. Y equals 45 divided by X. look at your table, look in your y1, look for the largest number on your y1 list that's on your perfect square list. 45 isn't, 22.5 isn't, 15 isn't, 11.25 isn't, 9 is. I asked you to try number 4 on your own. If you didn't already, then pause it and do it right now. If you're asking for BD, HLLS or SAAS, well, there's an A involved, so I'm using SAAS. There's a little twist here. Since this whole thing is 16, to find DA, I would have to subtract 16 and 7 to get 9. Because that 16 is H. I'm not using H in SAAS. So it will be 7 over X equals X over 9. Cross multiply. X squared equals 63. Square root, square root. 63 is not on my list, so I go into reducing radical mode. What's the largest number on that list that goes into 63? Well, 63 would be here. Can't divide it by 49. Can't divide it by 36. No, no. I can divide it by 9. 9 and 7. So my answer becomes 3 rad 7. All right, I just want to go over one more with you. An annoying question. There's a couple of annoying questions. So 9 and 10 are kind of annoying. So I'm going to go over number 9. It's annoying because I basically have to go through each choice and do the problem 4 times to see what happens. So it says which lengths would make triangle KLM a right triangle. Well, if it's a right triangle, that means that your Hill-SAS proportions hold true. So I'm going to have to go through each choice. So choice 1, LM is 13. And KN is 6. So first off, if KN is 6 and this whole thing is 16, that would make NM 10. Because there's a leg involved, I would do Hills. H is 16 over L is 13 equals L is 13 over S. If I'm using the right leg, I'm using the right seg. That would be 10. When I cross multiply and solve, I get 160 equals 169. Does that proportion hold true? No. Therefore, choice 1 can't be the lengths of those segments. So now I erase and I take a look at choice 2. LM is 12, NM is 9. That would be Hills again. 16 over 12 equals 12 over 9. I got a good feeling about this one. 16 times 9, use a calculator if you need to, is 144. 12 times 12 is 144. This one evens out. This one looks good. However, I like to always go through all 4 choices, just to be sure that I didn't make a mistake somewhere. Choice 3, KL is 11, KN is 7. Again, this would be Hills because there's a leg involved. 16 over 11 equals 11 over 7. 16 times 7 is 112, I believe. 11 times 11 is 121. Those are not equal. Therefore, those can't be the lengths. And finally, choice 4. Let's try and do a fun new color, like orange. Yeah. LN is 8, NM is 10, which means that since this whole thing is 16, this piece is going to be 6. There's no leg involved here. This would be SAS, because there's an altitude involved. 6 over 8 equals 8 over 10. 8 and 8 is 64. 6 and 10 is 60. They don't equal out, so those can't be the sides. If you enjoyed that orange, it was a blast. Choice 2 is your answer. So it's annoying because you're going to have to go through all four choices and do the problem 4 times. But, as long as you know how to do HLLS, it's not bad. 10 is pretty much the same type of thing. You're going to have to go through each choice and set them up and see which one gives you that as your answer. And 11 is just a word problem. I'll give you a hint to get you started on it, but other than that, I'm not going to do it. It's just about reading. It's giving you a bunch of values. The question is, how much further in feet is Nikki's walk from the elephant compound to the tiger preserve than Albert's walk from the lion exhibit to the tiger preserve? So it wants to know, first of all, which is longer, Nikki from the elephant compound, so the elephant compound to the tiger preserve, elephant compound to the tiger preserve, or lion exhibit to the tiger preserve. So basically, you're going to have to find each of those, and to find one of them, I would start by finding x. Because there's no altitude involved, there's a leg involved, you're going to use hills. And once you get that piece of information, then you can roll from there. So it's just the wording that I know students can have a little bit of trouble with, so I wanted to give you a little bit of hint there. But other than that, it's pretty straightforward. So listen, this is a very important lesson Regents-wise. They ask it on, they're definitely going to ask you HLLS. A radical is very likely to come up somewhere, and likely they come up in the same question. So, to do HLLS, determine if there's a leg involved or an altitude involved. If there's a leg involved, use hills. If there's an A involved, use SAAS. And if you have to reduce a radical because you have x squared equals something that's not a perfect square, you're going to separate into your perfect squares and your non-perfect squares. You're going to use your perfect square list. You can use the calculator trick. Again, the calculator trick would be, for this one here, if I want to reduce 12, it would be y equals 12 divided by x. And then you look at your table, and you're looking at y1 for the largest number that's on the list. Your classwork/homework is to finish this, and that's it. I hope everyone has a great day.